Afternoon, everyone. So it's already 1:05. So we'll start today's topic: open systems interconnection. Open systems interconnection reference model is one of the basic model which is used for us to understand how communication takes place between two computers in a computer network. It is called a reference model. Why it is called as reference model? Because it is used to just understand how each layer functions. What is the function of each layer? What are the different types of protocols in each layer? It just gives us the reference. That's why it is called as a reference model. There is another type of the reference model, that is TCP by IP. We will discuss it later. In today's class, we will go through this open systems interconnection reference model. This model is the foundation for all communications that takes place between computers and other networking devices. Okay, so excuse me, it is the foundation for all the communications, and this model was proposed by International Standards Organization ISO in 1977. This model is called open systems interconnections because the model allows any two different systems to communicate regardless of their underlying hardware and software heterogeneity. So it is the important point here. Why it is called as open systems? Generally, in the basic form, whenever we want to connect two computers, the two computers are connected by using a simple LAN cable and connectors, and data is shared between those two computers by using network interface card. No problem if they are working on the same network. For example, if one computer is having different hardware and software and another computer is having different hardware and software, they are not homogeneous in nature. They are heterogeneity. Heterogeneity means they are having different hardwares and softwares. For example, if one computer is operating with Microsoft Windows and another computer is operating with Mac OS, then how the communication between those two takes place? It is possible with open systems interconnection. Okay, so here the open systems means whatever the software and whatever the hardware that is used in the computers, those two computers can be communicate without any restrictions. That's why the name open systems interconnection. Now we will see the architecture of that open systems interconnection. So this is the OSI reference model. Once look at the figure. It consists of 7 layers. First one is the physical layer. Second one, data link layer. Third one, network layer. Fourth one, transport layer. Fifth one, session layer. Sixth one, presentation layer. And the last one, application layer. So there is a small technique to remember these layers. That is, please do not tell secret password to anyone. Okay, please. Physical, so physical means please. Data link, do. Network, not. Transport, tell. Session, secret. Presentation, password. Application, anyone. So please do not tell secret password to anyone. So using that technique, we can remember these 7 layers in OSI reference model. Okay, so this is host A. This host A consists of these 7 layers. Similarly, the host B, so it is in another network. The host B is in another network. It also consists of the 7 layers. Here, application layer transfers data to the presentation layer. Here you have to remember one thing, the data flows always from top layer to the lower layer in the host A. In the sender side, the data always flows from upper layer to the lower layer. And the lower layers always provides services to the upper layers. The upper layers uses that services, but they don't know who provides those services to them. Okay, so the lower layers are always the service providers and the upper layers are always the service users. Here, the communication between each layer inside the host A is the direct communication. Again, look at here. This is host A and this is host B. The communication between same layers of different machines. For example, in host A, the first layer is the physical layer. In host B, the first layer is the physical layer. So the communication between these two is known as physical layer protocol. Similarly, the communication between the second layer, data link in host A and data link in host B. So it is known as data link protocol. Similarly, network link protocol, transport protocol, session protocol, presentation protocol, and finally, application protocol. So the protocol means virtual communication that takes place between same layers of different machines. Okay, so this is about the OSI reference model. Remember one thing, in host A, that is in sender, the information is passed from the top layer to the lower layer. And when the data reaches the lower layer, that is the physical layer, then the data is transferred through the physical medium to the host B and it reaches the lower layer and the data is transferred from lower layer to the uppermost layer in the sender. Okay, in the receiver. In the sender, the data is flowed from high level to low level, and in the receiver, the data flows from low level to high level. You have to remember that thing. Okay, so that's why I will explain from 7th layer onwards to the first layer. So first we will discuss about the 7th layer. So before going that, we will see how these layers are organized in this OSI reference model. So this is the organization of layers. Organization means how these layers are moduled and constructed in this reference model. First one, each layer in OSI model performs specific functions. So there are 7 layers. One layer is a physical layer, another data link, another network. So these 7 layers performs 7 unique and specific functions. The function performed by one layer is not performed by the other layer. Okay, they performed their unique functions. Each layer is independent from every other layer in its purpose and responsibilities. Okay, so every layer is independent of the other layer and they are isolated from each other. There is no connection between them. Only the data will be flowed between them through the direct communication. They are isolated. This information by each layer is added in the form of headers or trailers. This process of adding information to data as it passes through the layers is known as encapsulation. Okay, so what is meant by encapsulation and what is meant by decapsulation, we will look at here. I had already told you in host A, that is in sender, the data always passes from high level to lower level. From 7th layer to 6th layer, from 6th to 5th, like that, the data flows. So when there is a data in the application layer, when it comes to the 6th layer, that is presentation layer, some header is attached to that data. Okay, so with that header, the data reaches to the 5th layer. So here also again some header is attached to the data. So from session layer, the data reaches the transport layer. Here again some header is attached. So like that, as the data passes from the high level to the lower level, headers are attached to the data as it travels from the upper position to the lower position. Okay, so finally, when it reaches to the physical layer, the data consists of a header as well as trailer. So the data along with the header and trailer is known as encapsulation. Okay, the data along with the header and trailer is known as encapsulation. So these data passes through the physical medium and it reaches the host B. And when it reaches the physical layer in the host B, those header and trailer are eliminated. As the data goes on moving to the upper positions, the headers are removed. So finally, when it reaches the application layer, it gets only the message without any headers and trailers. So the process of removing headers and trailers is known as decapsulation. So simply we can say that in the sender, encapsulation takes place and in the receiver, decapsulation takes place. Okay, so this is about how the layers are organized in OSI reference model. So first one, each performs its specific functions and they are independent, they are isolated, and in the sender encapsulation takes place, which is nothing but adding headers and trailers to the data, and in the receiver decapsulation takes place, which is nothing but headers and trailers are removed gradually as the data moves from the lower layer to the upper layer. So first I will discuss about layer 7, application layer. Why I am explaining the layer 7 instead of layer 1? Because in the sender side, the data, the message is transferred, is flowed from high level to the lower level. As the message passes from the higher level to the lower level, headers, trailers are added to that data. Okay, so first we will see about the application layer. This application layer is the topmost, that is the 7th layer of the OSI model. So if you look at the figure, this is the 7th layer. Application layer is the topmost of all the layers. So here you don't get confused that application layer consists of applications. These layers doesn't consist of any applications or anything. These all layers consist of protocols. Protocols means some set of rules and methods. Similarly, in this topmost, that is the 7th layer, application layer, it also consists of some protocols that are used to perform some network applications. What are network applications? Network applications are nothing but computer applications. Then what are computer applications? Computer applications are those applications which uses internet for their implementation. Computer applications are those which require internet for their implementation. For example, Google Chrome. One more example, Mozilla Firefox. Likewise, Skype, Outlook. So these are all the computer applications which uses internet. Okay, so in this application layer, these Chrome and these Firefox and Outlook are not included. These application layer consists of protocols to implement these applications. Okay, do you get the point? So for if you want to browse some data, we have to use Google Chrome. So for this, in this application layer, it consists of protocol. So what protocol is used for Google Chrome? It requires HTTP protocol, HTTP or HTTPS, Hypertext Transfer Protocol. Similarly, if you want to email, then we simply uses SMTP protocol. SMTP protocol means Simple Mail Transfer Protocol. Okay, so for web surfing, for email, for virtual terminals, for all these applications, different protocols are included in the application layer. So once we will look at that, it enables the user, whether human or software, to access the network by providing user interfaces. It provides services that directly support user application such as database access, email, and file transfer. So network virtual terminal, these are the functions of the application layer. These functions are achieved by this application layer by providing protocols, different types of protocols. For network virtual terminal, these virtual terminals are nothing but data terminal equipments. Data terminal equipments which are accommodated in the same network, which are having different bit rates, different protocols, different ports, whatever may be. So in order to implementation of that virtual terminals, it requires a protocol, that is telnet. Similarly, second function is application layer is used for file transferring, accessing, and management. So that is done by the protocol FTAM, File Transfer Access Management Protocol. Next, mail services, email services. Email services is through the protocol SMTP, Simple Mail Transfer Protocol. Next, directory services, that is web services, www web services, that is through HTTP or HTTPS. So all those applications, computer applications which uses internet, those applications are achieved by using the protocols provided by the application layer. Next, presentation layer. The name itself gives us indication that presentation, how the data is presented. Presentation layer is the sixth layer of the OSI model. It is concerned with the syntax, semantics of the information exchanged between the two devices. How the data from the application layer is to be reached to the presentation layer, and how that data is sent to the next layer, session layer. ఓకే సో ప్రెజెంటేషన్ లేయర్కి మా అప్లికేషన్ లేయర్ దగ్గర నుంచి డేటా వస్తుంది. ఆ వచ్చినటువంటి డేటాని నెక్స్ట్ దాని కింద ఉండేటువంటి లేయర్ సెషన్ లేయర్కి ఏ విధంగా ప్రజెంట్ చేస్తుంది అనేది దట్ ఫంక్షన్ విల్ బి క్యారీడ్ ఇన్ ద ప్రెజెంటేషన్ లేయర్. సో దీస్ ఆర్ ద ఫంక్షన్స్ ఆఫ్ ద ప్రెజెంటేషన్ లేయర్. We will see one by one. Data presentation or translation. Data presentation or translation. So here the presentation layer receives data from the application layer, because application layer is the 7th layer, and that 7th layer provides data to the 6th layer. Here the 6th layer is the presentation layer. This presentation layer receives data from the application layer. Here, whatever the data received by this presentation layer is in the form of some characters and numbers. Okay, the data received by the presentation layer is in the form of characters and numbers. But that characters and the numbers are not understood by the machine. So what to do? We have to transfer that characters and the numbers into some machine understanding binary format. Okay, so one best example is ASCII to binary, extended binary coded decimal interchange code, that is EBCDIC code. Okay, so ASCII code is converted to EBCDIC code. So here ASCII code is translated to some another code, that is known as translation. So why here we are using the translation? Because the machine can't understand the characters, the machine can't understand the numbers, so it requires some special language, some machine language. So for that, here the data is translated. So that is known as data presentation or translation. So this function is performed by the presentation layer. Whatever the data the presentation layer received from the application layer is translated into machine language binary format. Next, data compression. Very, very important one, data compression. Why the data is compressed? For example, if the data is not compressed, then it occupies more space. Not only that, once if data is compressed, it occupies less space. For example, if some data occupies 5 MB, 5 MB data is there for some data. If we use compressing techniques, if the data is compressed to 2 MB, then here the space occupied will be less, and it takes less time for the transmission of the data from the sender to the receiver. Is it not? How much time it takes for transferring of data if it is 5 MB and if it is 2 MB? So if it is 2 MB, it takes less time. So if the data is compressed, it increases the speed of operation. That's why the data is not only translated, but the data is also compressed for quick transmission. So here, this data compression technique is also provided by this data compression technique function is also provided by this presentation layer. Next, third one, data encryption and decryption. So what is the necessity of encrypting data? So encryption is meant for providing security. Our data must be in a secure position. It must not be sensitive to hacking. Okay, so to protect our data, here the bits are, whatever the bits in the binary format are again encrypted. Okay, so first thing is data is translated, then it is compressed and it is encrypted. So these all things happen in the sender side only. Okay, so data is translated, it is compressed and it is encrypted. Now the data is to travel through the physical medium and it should reach the receiver. So when it reaches the receiver, the data has to be decrypted. Okay, so that data has to be decrypted. So in the sender side, encryption takes place, and at the receiver side, decryption takes place. So for that, some protocol must be provided by the presentation layer. So that protocol is nothing but SSL protocol. SSL protocol means Secure Sockets Layer Protocol. So this secure sockets layer protocol is provided by the presentation layer, which encrypts the data at the sender side and decrypts the data at the receiver side. So these are the functions performed by the presentation layer. So whatever the data that it receives from the application layer is translated, compressed, encrypted, and decrypted. Okay, the next layer is the session layer. The session layer is the fifth layer of the OSI model. So session, for example, we are conducting the Zoom classes. So before conducting the Zoom class, what we have to do, we have to create a schedule. We have to create a schedule for session. Okay, so first, like that here also, whenever the session layer receives data from the presentation layer, it has to schedule a session. It has to schedule a session. So that is the primary responsibility of this session layer. Session layer has the primary responsibility of beginning, maintaining, and ending the communication between two devices, which is called session. So if data is to be transmitted between a computer A and a computer B, then the function of this session layer is to establish a connection between those two computers. Not only establishing connection, it has to maintain that connection. Maintaining means the session should not be abrupted suddenly. It should not be stopped abruptly. Okay, so maintenance. Maintenance means to look after how it is working. Okay, next, beginning, maintaining. So after the session is completed, it should be terminated. It should be ended. So all these three functions must be performed by the session layer. It also provides for orderly communication between devices by regulating the flow of data. So it not only begins, maintains, and ends the communication between two devices, but it also provides orderly communication. By which protocol? By using the flow of data protocol. Okay, so this is about the session layer, and we will see what are the functions and what are the protocols provided by the session layer. So first thing, establishment, maintaining, and ending a session. Okay, so here when one computer want to establish a connection with a server, then what that server does, the server wants authentication. So authentication means what is your username, what is your password. So all those details are required by the server. That is authentication. Okay, so after authentication only, it establishes the connection. After the connection is established, data transfer takes place. After the data transfer takes place, the session will be ended. So all these functions, all these protocols will be provided by the session layer. After that, dialogue control. So this is very important one, dialogue control. Dialogue control means whether the communication between the two computers will be simplex or half duplex or it be in full duplex. So that is also provided by this session layer. Okay, so the dialogue control may be simplex or half duplex or full duplex. What is meant by simplex? Simplex means only one-way communication. Okay, if the sender, only the sender sends the data, only the sender transmits the data. The receiver doesn't sends the data. Okay, so it is only one directional. For example, monitor or keyboard. So we will just give inputs to the computer through the keyboard. The keyboard doesn't give us any uh, uh, what you say, it doesn't give us any output to us. Okay, so only one way. Next, half duplex. Half duplex means data can be transmitted from one side, sender side, as well as data is also sent from receiver side, but not simultaneously. That's why it is half duplex. So data can be sent from sender. Data can also be sent from receiver, but one after the other. If sender sends some data, then receiver has to wait. When receiver sends data, then sender has to wait. Both has capability to send the information, but not simultaneously, one after the other. For example, walkie-talkie. So in walkie-talkie, if one person speaks in the walkie-talkie, the other person has to listen it completely. After the first person stops talking, then the second person starts talking. Okay, so both persons can talk, but one after the other, not simultaneously. That is half duplex. Next, full duplex. Full duplex means both can talk simultaneously, both can converse simultaneously, like our telephone lines. So which type is used for communication, either simplex or duplex or half duplex? That is decided by this session layer. That is known as dialogue control. Next, dialogue separation or synchronization. This is also a very important topic. Dialogue separation or synchronization. For example, I want to send 10 pages of data from sender to receiver. Okay, so here that 100 pages from send to receiver. Here, those 100 pages is nothing but a dialogue. For example, those 100 pages are dialogue here. So here we have to separate that dialogue. Dialogue separation means that one. So we have to send 100 pages of data from sender to receiver. Here those 100 pages are divided into dialogues, dialogue separation. For example, 20, 20, 20. From first page to 20 pages, that is one dialogue. 21st page to 40 pages, that is second dialogue. 41 pages to 60 pages, that is third dialogue. 61 pages to 80, fourth dialogue. 81 to 100. So here the dialogue, the data is divided, the data is separated, that is known as dialogue separation. It is also called as creating checkpoints. Checkpoints. Okay. So here the purpose of this checkpoints is when we are transferring data from sender to receiver, first we send 1 to 20 pages. Okay, so that is first checkpoint. If there is no error there, all those 20 points are received by the 20 pages are received by the receiver. The receiver, after receiving the 20 pages, it sends an acknowledgement to the sender that I had received the first checkpoint, or I have received the first dialogue separation. That means 1 to 20 pages are received by the receiver. Then the sender sends next dialogue separation, that is from 21 pages to 40 pages. So when this 21 to 40 pages are received by the receiver again sends acknowledgement that I had received a second checkpoint, or I had received a second dialogue separation. Okay, so 40 pages are reached to the receiver without any interruption. For example, if there is some error in transmission of the 45th page, okay, so then the receiver then the receiver informs the sender that I didn't receive the third checkpoint to the sender. So the sender need not to check up to 40 pages because 40 pages are already reached to the receiver and the receiver had already sent the acknowledgement. So here the sender has to check only from the 41st page. It makes the correction easy. So that is known as dialog separation or synchronization, creating checkpoints. So this is the function performed by the session layer. So the session layer establishes, maintains, and ends a session. It decides how the communication to be either simplex, half duplex, or duplex, or it creates checkpoints. Okay, so these are the functions performed by the session layer. Next, the fourth layer, that is the transport layer. The transport layer is the fourth layer of the OSI model. It is responsible for source to destination delivery of entire message. The process is an application program running on machine. Okay. Next, in order to deliver the message between specific process running on source and destination, transport layer adds service point address of that application. This is very, very important one. In the starting of the class, I had already told you when the data is flowing from the application layer to the physical layer in the sender side, headers and trailers are added. Okay, what I had told you, headers and trailers are added. So the starting of headers and trailers are added from this layer only, from the transport layer. Okay, so first we will look at that. After that, we will look at the two services provided by the transport layer. So look at this. This is the segmentation of message into packets and reassembly of packets into messages. This is the first function performed by the transport layer. Whatever the data it receives from the session layer, so that data is divided into small packets. Okay, so that is known as segmentation. Okay, hope you understand. So whatever the data the transport layer receives from the session layer, here the transport layer breaks that data into segments. Okay, so these segments are reached to the lower layer, physical layer, and from the physical layer they travel through the physical medium and reaches the host medium. In the host medium, here these packets are again reassembled to form a single message. Okay, so it will be better understood from another figure. I will show you that. So that slide is missed somewhere. So just look here. This is data unit 1 and this is data unit 2 and this is data unit 3. Like that, here the whole data is divided into 3 segments, 3 packets. Data unit 1, data unit 2 and data unit 3. So here each data unit again consists of port number and sequence number also. Okay, each data unit again internally consists of one port number and sequence number. Port number is used for to which application it has to be connected. For example, the first unit, data unit 1 is connected to WhatsApp. Similarly, data unit 2 is connected to Google Chrome. Data unit 3 is to be connected to the application Firefox. So to which application this data packet is to be connected is specified in that port number. Next, there is a sequence number like this DU1, data unit 1, data unit 2, data unit 3. So these sequence numbers are used to reassemble these data units in the receiver side. So when it reaches the receiver, there is no necessity that they have to be reached in the sequence. First, the data unit 3 may be reached, after that 1 may be reached, after that 2 may be reached. So in order to assemble that in a sequence, that sequence number is required. So each data is divided into segments, and that segments are called packets. In transport layer, the data is obtained in terms of segments. Okay, so this is about segmentation. Next, coming back, connection management. Connection management means there are two types of connections, connection oriented and connectionless services. I had already explained about these services in the previous classes. I had explained you this. So connection oriented services are, it contains three phases. First one, connection establishment, next data transfer, and next third one is connection releasing phase. So in connection oriented services, the main advantage is the receiver gives an acknowledgement after receiving the data. Okay, so whenever sender sends some information to the receiver, after receiving that data, the receiver gives acknowledgement to the sender that I had got the message. Okay, so for example, email. For example, register services, register mails. Okay, so this comes under the connection oriented services. Next, connectionless services. So in connectionless services, there is only one phase, that is the data transfer phase. Since it is connectionless one, there is no need to establish a connection. There is no need to disconnect the connection. Only data transfer takes place. Okay, so here there is no acknowledgement. There is no need for acknowledgement. For example, if we are watching a movie, okay, we are downloaded some movie and we are watching the movie. There is no need to give acknowledgement that I am watching the movie. Similarly, we are conversing on a telephone line. So there is no need to give us acknowledgement to the sender that I am speaking to you. You are speaking to him. That is the acknowledgement itself. Okay, so this is about connectionless service. So what type of services are to be used is decided by this function, by this transport layer, whether connection oriented or connectionless. Next, flow control. Flow control is one of the very important function of this transport layer. How the flow is controlled. I will explain you this by another diagram. So look at this. So for example, flow control. Okay, I am explaining the function of the transport layer, which is nothing but the flow control. For example, here there is a server and here is some mobile. The speed of the server is 100 Mbps and the mobile is 10. So this mobile has to download some data from the server. Here, the server starts sending that data with a speed of 50 Mbps. Okay, so here, what is the speed of this mobile? Only 10. But here, the server is sending the data with the speed of 50 Mbps. Okay, so then this mobile, through the transport layer, sends a feedback to the server, please decrease your speed because my capacity is only 10 Mbps. You are sending the information with 50 Mbps. Okay, so this is the feedback provided by the mobile to the server through the transport layer. For example, if the server sends the data with 5 Mbps, here the speed of the mobile is 10 Mbps. So at that time, again, this mobile can send feedback through the transport layer that to increase the speed because it is capable of 10 Mbps, but the server is sending only 5 Mbps of data. Okay, so this is known as flow control. Flow control is nothing but the feedback sent by the receiver through the transport layer to the sender to maintain synchronization in order to provide, in order to control the loss of data. So this function is provided by the transport layer. Next, error control. Error control is also one of the important function of this transport layer. So when sender sends some data to the receiver must exactly reach whatever the data the sender sends to it. Okay, so if it doesn't reaches the exact data sent by the sender, then we can say that there exists some error. Okay, so those error can be rectified by using error control, that is the function performed by the transport layer. So I will explain this by another diagram. Okay, so look at here. So here this is the server and this is the mobile phone. So here the data is divided into 3 segments: data unit 1, data unit 2, data unit 3. But at the receiver, here only 2 data units are obtained, data unit 1 and data unit 3. So data unit 2 is missing here. So at that condition, here the receiver can send automatic repeat request. Automatic repeat request means it again requests the sender to send the data again. To send the data again. So when the sender again sends the data, at that time the receiver may receive all the 3 units, DU1, DU2 and DE3. Okay, so this is one technique for rectifying the error. Another technique is redundancy check. I had already explained you in the previous classes, redundancy check. Redundancy check means some group of bits are added to the data unit. Okay, some group of bits are added to the data unit in the sender. So that are known as redundancy bits. When these data unit along with redundancy bit reaches to the receiver, in the receiver there is some redundancy check function. So this redundancy check function compares the information received to it with this function. If that function is valid, then it is an error-free data. If that function is not valid in the receiver, it is an errored data. Okay, so error can be controlled either by sending automatic repeat request or by using redundancy check. These are the 2 techniques to rectify the error. So this function is performed by the transport layer. Okay, so once again, I am explaining the functions of the transport layer. First function is it whatever the data it receives from the session layer is divided into segments. So this is segment 1, segment 2 and segment 3. So this is nothing but each segment is called as a data unit, and in the data unit it consists of the port number and the sequence number. So this is data unit, it consists of port number and sequence number. Likewise, so here this port number is used to which application we have to connect that layer, whether to Chrome or WhatsApp or Firefox. Okay, so for each application we want to connect. And this sequence number is used for reassembling the message in the receiver. Okay, so these are the functions performed by the transport layer. Okay, so the time is already 50 minutes. For today, it's enough. Once I will go through the topics, what I had discussed up to now. So, open systems interconnection. Open systems interconnection is the basic model for the interconnections between 2 different computers in different networks. The main purpose of this interconnection model is even though the hardware and software in the two computers are different, it can provide communication. Okay, so that is the important advantage of this OSI model. That's why it is called as open systems. It is open for communication, even though the computers are having different hardwares and different softwares. So it consists of OSI reference model consists of 7 layers. So once again, I am saying that word to remember these 7 layers. Please do not tell secret password to anyone. So అది గుర్తుపెట్టుకుంటే కనుక మీకు ఈ లేయర్స్ అన్ని గుర్తుంటాయి. So first layer is physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and finally application layer. In host A, the data is transferred from higher layer to the lower layer. The data flows from upper layer to the lower layer, 7th layer to 1st layer. And the data passes through the physical medium, and in the host side, the data travels from lower layer to the upper layer. So that's why here I am explaining from the 7th layer, application layer. So this is the organization of layers. Here each layer performs specific functions and they are isolated from each other and they are having their own independency from each other. And when the data flows from the higher layer to the lower layer in the sender side, it is called encapsulation because the data is provided with headers and trailers. When it reaches the receiver, all those headers and trailers are removed as the data moves from the lower layer to the top layer. That is known as decapsulation. And application layer. The purpose of this application layer is to provide application protocols like HTTP or HTTPS for web browsing and SMTP protocols for emailing and Telenet for virtual terminals. So these protocols are provided by these application layers. Next, these are the functions. Presentation layer. The presentation layer receives data from the application layer and it presents the data by translating it, by compressing it and encrypting and decrypting it. Okay, it encrypts the data in the sender side and decrypts the data in the receiver side. It compresses the data for speed upping of the transmission and it translates the data for the convenience of the machine. And this is the session layer. The function of the session layer is to establish a session, to maintain the session and to terminate the session. So establishment, maintaining and ending a session, and here is the dialog control. So whether the information, whether the transmission has to be done either in simplex form, duplex form, or half duplex form, and next creating checkpoints. And finally, the transport layer. So in the transport layer, the data received from the session layer is converted to segments. In tomorrow's class, I will ask you, so how will be the data in the transport layer? In the transport layer, the data is in the form of segments. Okay. So the functions performed by the transport layer are flow control, error control, and the connection management, connection oriented or connection. Okay, so if you have any doubts, you can ask me. Raise your hand. If you have any doubts, ask me. Raise your hand. Okay. Otherwise, I will end the session.